The story of penicillin began with an accident, a drop of mold on a forgotten Petri dish, a scientist who didn't throw it away. And from that tiny moment, a chain of events that would save more lives than any war had ever taken. Before penicillin, a simple infection could kill. A scratch, a cut, a cough, all could end a life. After penicillin, humanity had hope. Hospitals were no longer places of fear, but of healing. Medicine became a science of victory, not surrender. By the end of the 20th century, antibiotics had saved over 200 million lives. The average human lifespan doubled. Surgery, childbirth, even cancer treatment, none of it would be possible without the miracle born in Fleming's lab. But the legacy of penicillin is more than just medicine. It is a story about chance and what we do with it. Fleming didn't plan to change the world. He simply paid attention to something everyone else ignored. He was curious, and that curiosity became the seed of a revolution. Every discovery since then, DNA, vaccines, organ transplants, was built on the same idea, that even a small observation can rewrite the future. And yet, Fleming's warning still echoes today. Bacteria continue to evolve. New diseases emerge. The miracle he gave us is not eternal. It must be protected. Scientists across the world now search for the next penicillin. A new cure, a new miracle, another spark of hope. In labs from Tokyo to New York, young researchers grow cultures, mix chemicals, and watch for signs. Perhaps another mold, another accident, another story waiting to begin. Because that is Fleming's true legacy. Not just the drug that saved millions, but the belief that one human mind can change the destiny of the entire species. In 1955, when Fleming passed away, his colleagues placed a small Petri dish on his grave, a circle of glass that once held the world's greatest discovery. And on it, a few words were written: "The man who found the mold that saved the world." From a drop of mold to the dawn of modern medicine, this was not just science, it was faith. Faith in observation, faith in persistence, faith that even the smallest things can save us all. The world may face new enemies, but the lesson remains the same. Miracles are not given, they are found. And sometimes, they begin with a mistake. It began as a whisper, a quiet concern buried beneath the noise of victory. The world was healing, yes, but something else was growing. Something dangerous, invisible, and patient. In 1945, during his Nobel Prize speech, Alexander Fleming said words that few wanted to hear. "There is the danger that the ignorant man may easily underdose himself, and by exposing his microbes to non-lethal quantities of the drug, make them resistant." People applauded, smiled, and then forgot. Because how could anyone believe that this miracle, this savior of millions, could ever turn against them? By the early 1950s, penicillin was everywhere. Doctors prescribed it for everything: coughs, colds, even headaches. Factories produced it faster than ever. Pharmaceutical companies advertised it like candy. One shot, one cure. No tests, no caution, just faith in the miracle. But nature was watching. Deep inside hospitals, something strange began to happen. Patients who had been cured weeks before came back. Same infections, but stronger this time. Penicillin no longer worked. The bacteria were learning. Doctors saw it first in London, then in New York, then everywhere. The invisible enemy had adapted. They called it resistance. Fleming's warning was coming true. He had spent his life studying how microbes fought to survive, how even a tiny drop of antibiotic could push them to evolve. And now, humanity was feeding that evolution, dose by dose. By the 1960s, scientists realized that penicillin alone could no longer save everyone. New antibiotics had to be created, stronger, broader, faster. It was a biological arms race. Every new drug brought a new mutation. Every victory was temporary. Still, The world didn't stop. The drug industry grew richer. Farmers began using antibiotics in animals to make them grow faster. Ordinary people demanded pills for every sickness. The miracle had become a habit, and habits have consequences. When Fleming died in 1955, his final interviews carried the same message, a message humanity would not fully understand for decades. The time may come when penicillin can be bought by anyone in the shops. Then there is the danger that the ignorant man will underdose himself and, by exposing his microbes to non-lethal quantities of the drug, make them resistant. It sounded like science fiction then. Today it sounds like prophecy. Fleming had given the world a weapon against death, but like all weapons, it depended on who held it. The mold that once saved the world had started to lose its power, not because it changed, but because we did. The war was over. The guns had gone silent, but something far greater had begun. A new war, not against nations, but against disease. Across the world, hospitals were filled not with soldiers, but civilians. Mothers, children, workers. The same infections that once killed millions, pneumonia, sepsis, meningitis, were suddenly losing their power. And the reason was a tiny vial of golden liquid, penicillin. Factories that once built tanks were now producing medicine. Pharmaceutical companies raced to make enough for every hospital. In New York, Chicago, London, even in small towns, doctors lined up for supplies. The miracle drug that saved soldiers was now saving ordinary people. In 1946, the headlines read, "The war hero now fights disease." The hero was not a man. It was penicillin. For the first time in history, children survived infections that had always been fatal. Women survived childbirth without fever. Injured workers returned home instead of being buried. Families stayed whole. The invisible killer had met its match. And with every recovered patient, a new dream was born. If one mold could save the world, what else could science discover? Scientists everywhere began searching for new antibiotics. Streptomycin, tetracycline, erythromycin. The antibiotic era had begun. Medicine was no longer about praying for recovery. It was about finding the cure. But not everyone celebrated. Alexander Fleming, now a global hero, gave a warning in one of his last interviews. If you use penicillin incorrectly, you can teach bacteria to resist it. It sounded like a small concern at the time, but it was the first shadow of a problem humanity would face decades later. Still, in the late 1940s, hope filled the air. Posters across Europe showed smiling nurses and slogans. Penicillin saves lives. Doctors carried small cases marked with the blue cross, symbols of healing, of science, of survival. In classrooms, children learned the name Alexander Fleming alongside other great heroes of the century. He wasn't a general or a politician. He was a quiet man who made a mistake. And that mistake saved the world. By 1950, more than 200 million doses of penicillin had been produced. And by the time Fleming passed away in 1955, the world he left behind was unrecognizable from the one he was born into. A world where a simple infection no longer meant death. A world where science had given humanity a second chance. The war had destroyed cities, but from the ruins rose something new. Faith in knowledge, in discovery, in progress. The mold that grew by accident in a London lab had become the symbol of hope for an entire planet. The war was over, but the age of healing had just begun. June 6, 1944, D-Day. Thousands of ships approached the beaches of Normandy. Waves of soldiers ran into gunfire, explosions, and chaos. Within hours, the sand turned red. And behind the front lines, doctors prepared for what they knew was coming. An ocean of wounded men. For centuries, infection was the real killer of war. Not bullets, not bombs, but the invisible enemy that entered every open wound. Even a small cut could turn deadly within days. Surgeons knew it too well: gangrene, sepsis, fever, death. No matter how skilled the doctor was, infection always won. Until now. Inside field hospitals, American medics opened small glass vials labeled simply penicillin, the drug that began in a forgotten London lab. The mold that Fleming had once thrown away was now saving lives on the beaches of France. Doctors injected wounded soldiers and waited. For the first time, they didn't see wounds turning black. They didn't see men dying of fever. They saw something no one expected: healing. Within 24 hours, soldiers who were near death began to recover. Infection stopped spreading. Amputations dropped. And word spread through the camps. They've found a miracle. The Allies carried penicillin in every medical kit. Each dose was more valuable than gold. In the first months after D-Day, penicillin saved tens of thousands of soldiers, men who would have been lost in every previous war. It was the silent weapon that turned the tide of suffering. By 1945, penicillin production exploded. Factories across the United States and Britain ran day and night. What once took weeks in a lab now poured out of steel tanks by the gallon. The price of a life-saving dose dropped from hundreds of dollars to just a few cents. And when the war finally ended, another battle began, to bring this miracle to civilians. Hospitals around the world began using penicillin on ordinary people: mothers with infections after childbirth, children with pneumonia, workers injured in factories. For the first time in human history, a bacterial infection was not a death sentence. Alexander Fleming, Howard Florey, and Ernst Chain, three men who had never planned to be heroes, stood together in 1945 as the world thanked them. They were awarded the Nobel Prize in Medicine. And when Fleming stepped to the microphone, he said words that still echo today: "Nature makes penicillin. I only discovered it by accident, but it was no accident. It was humanity's stubborn will to fight death and to win." The mold that saved millions was born in a petri dish, grew in a basement, traveled across the ocean, and changed the fate of mankind forever. By 1941, the world was on fire. London burned under German bombs, hospitals overflowed, and in a small Oxford basement, a handful of scientists were fighting a different war, a silent one. Their enemy wasn't Germany. It was infection. And their only weapon was a few drops of yellow liquid called penicillin. Florey, Chain, and Heatley knew they had something extraordinary, something that could change medicine forever. But they faced an impossible challenge: how to make enough of it. Every test, every patient, used up nearly everything they could produce. The mold grew slowly and produced almost nothing. They needed gallons of it, not for one man, but for thousands. They tried everything. They filled rooms with trays of culture, bedpans, milk jars, even old food tins. They built makeshift incubators out of heating pipes. The air smelled of damp earth and fungus. Every surface in the lab was covered in green-blue mold. It was chaos, but it worked, just barely. Then, one night, Florey made a decision. He looked around the cramped Oxford lab and said quietly, "We can't do this alone." If they wanted to save lives, they needed help, industrial help. And that meant America. In the summer of 1941, with war raging across Europe, Howard Florey and Norman Heatley boarded a military transport plane to the United States. They carried something priceless: a small bundle of penicillium spores, hidden inside the fabric of their coats, in glass vials, even smeared inside their pockets, in case their luggage was lost. If the plane went down, the mold might still survive. They arrived in Peoria, Illinois, a quiet American town with a government research lab known as the Northern Regional Research Laboratory. There, American scientists listened to their story with disbelief. A mold that could stop infections. It sounded like science fiction, but when they saw it work under the microscope, they understood. This was real. This was hope. Soon, an alliance formed. British scientists, American chemists, and the U.S. government joined forces in what became known as the Penicillin Project. It was a race against time, to produce enough penicillin before more soldiers died. The Americans began experimenting with new methods. They discovered that penicillin mold grew better not on simple jelly, but in corn steep liquor, a waste product from corn factories. It was cheap, abundant, and perfect. Then, in a stroke of luck, they found a new strain of mold, not from a lab, but from a rotting cantaloupe in a Peoria market. It produced 200 times more penicillin than Fleming's original strain. Nature had just handed them a miracle. Again, factories across America converted part of their production lines to penicillin. Massive fermentation tanks bubbled day and night. Chemists worked 16-hour shifts. The first industrial antibiotics were born, and so was a new era of medicine. By late 1943, the first shipments of American-made penicillin reached the Allied armies. Small glass vials were sent to field hospitals where surgeons whispered about the miracle drug. For the first time in history, soldiers with infected wounds had a real chance to survive. Florey and his team watched from afar, proud and exhausted. They had done the impossible, turned a forgotten mold into a weapon of life. But the race wasn't over yet. The real test would come next, on the beaches of Normandy. Discovery is one thing. Recognition is another. When Alexander Fleming published his paper on penicillin in 1929, it made almost no noise. A few scientists glanced at it, nodded politely, and moved on. To them, it was just another odd experiment with mold. The world was busy chasing chemistry, not nature. The age of synthetic drugs had begun, and no one wanted to hear about a fragile liquid that came from fungus. Fleming tried to explain it. He showed his dishes, his notes, his photographs, clear zones where bacteria had vanished. He wrote letters to pharmaceutical companies, to research institutions, to anyone who would listen. But everywhere, he heard the same answer. "It's interesting, Mr. Fleming, but it's not practical." They were right. In part, penicillin was unstable. It couldn't be stored or mass-produced with the tools available in 1929. Within days of extraction, it broke apart. And in the busy laboratories of London, where time and funding were always short, no one wanted to waste resources on something that seemed impossible. So, Fleming's discovery slowly faded into the background. The Petri dishes dried out. His research notes gathered dust. By 1932, he had moved on to other experiments. Still a respected scientist, but no longer chasing the dream that once glowed in that circle of mold. Yet, he didn't forget. Whenever he lectured to students or colleagues, he mentioned it, a mysterious substance that could kill bacteria and leave human cells untouched. He knew its potential, even if no one else did. The 1930s were a decade of darkness. Economic depression spread across Europe. Nations rearmed, hospitals filled again with wounded soldiers and sick civilians, and infections, silent, relentless, kept claiming lives. By 1935, two other scientists, Gerhard Domach in Germany and Howard Florey in Oxford, began working in similar directions. Domach discovered Prontosil, the first sulfa drug, a chemical that could fight some infections. It was a medical revolution, but it wasn't perfect. Bacteria adapted quickly, and many strains remained untouchable. The dream Fleming once had, a true, natural antibiotic, still waited in the shadows. Fleming, now older, continued his quiet work at St. Mary's. He had no idea that across the city, in a small Oxford laboratory, another team was about to pick up where he had left off. Men like Howard Florey, Ernst Chain, and Norman Heatley would soon take that forgotten mold and give it new life. They would extract, purify, and multiply it, just in time for the deadliest war in history. But for now, in the early 1930s, it was still just a memory. A note in an old journal. A forgotten dish on a dusty shelf. Science had moved on. The world had moved on. And yet, in that quiet space between failure and hope, The story of penicillin was only beginning. 10 years passed. Europe was changing again, and not for the better. By the late 1930s, the world stood on the edge of another war. Armies marched, flags rose, and in quiet university towns, scientists worked by candlelight, chasing discoveries that could save lives or destroy them. In Oxford, a small, underfunded laboratory buzzed with quiet determination. It was the Sir William Dunn School of Pathology, a place where research was done with limited money but unlimited curiosity. Here, 3 men, Howard Florey, Ernst Chain, and Norman Heatley, came across an old scientific paper written by Alexander Fleming in 1929. Chain, a German-Jewish biochemist who had fled Nazi Germany, was intrigued by the strange description of a mold juice that killed bacteria. He showed it to Florey. They both read in silence. Then Florey said quietly, "We should look into this." They decided to repeat Fleming's experiment, to grow the same mold and test it again. The world had changed since 1929. Science had advanced. New equipment, better glassware, stronger microscopes, and above all, a new sense of urgency. War was coming, and with war came infection. By 1939, the team began to culture the Penicillium notatum mold in trays, jars, even bedpans. They didn't have enough funding or proper facilities. The lab smelled like damp earth and spoiled fruit, a strange mix of life and decay. But slowly, they began to extract a yellowish liquid that showed the same miraculous effect Fleming had seen years ago. Bacteria dying in perfect clear circles. Florey and Chain worked day and night, testing the liquid on infected mice. The results were stunning. The mice that received penicillin survived. Those that didn't died within hours. For the first time, the miracle had been proven. It wasn't just a laboratory curiosity anymore. It was a weapon against death. But there was a new problem. They couldn't make enough of it. Each batch of mold produced only tiny drops of the substance, and it degraded quickly. To treat one human patient, they would need thousands of liters of mold culture. It seemed impossible. So the team did the only thing they could. They improvised. Norman Heatley, the youngest member, built extraction systems out of milk bottles, bedpans, and old food tins. They filled entire rooms with trays of growing mold, kept at perfect humidity and temperature. It was a race against time and against the coming war. Then, in 1940, German bombs began to fall on Britain. The Blitz had begun. Hospitals overflowed with wounded soldiers and civilians. Infection spread through burns, shrapnel wounds, and surgeries done in dark basements. The need for penicillin became desperate. Florey's team tested it on the first human patient, a policeman named Albert Alexander, who had been badly infected from a small cut. They gave him penicillin, drop by drop. Within 24 hours, his fever dropped, his infection faded, and his pain lessened. It was working. But after 5 days, they ran out of penicillin. They even collected the man's urine, trying to recover and reuse every last drop. But it wasn't enough. Albert died. The team was heartbroken, but they had seen what was possible. Penicillin could save lives, if only they could make more of it. And so began the next great struggle, to turn a fragile discovery into a weapon strong enough to fight a world at war.